Hello everyone. Today we're going to talk about inverse variation. So in order to understand inverse variation, let's talk about direct variation and compare it. So what you would have known before today and right now is you would know that there is such a thing as direct variation. Direct variation is when y is equal to k times x, right? Some constant times x. This is going to be that linear function that you remember from Algebra 1. Today, we're going to bring in another kind of variation called inverse variation. Inverse variation is y equals k divided by x. So what you're going to see is in direct variation, as the x increases, your y value will also increase. In inverse variation, you'll get the opposite. As x increases, your y value will decrease. Okay, so they work inversely or opposite of one another. That being the case, that k value, so we are aware of the k value. The k right there, k is the constant of variation. So we do refer to it as a constant. Technically, it's not a constant because it's either being multiplied by a number or being divided by another number, but we refer to it as the constant of variation. It is the thing that is constant in a variation equation. Now, in direct variation, to find the k, you would do y divided by x. In inverse variation, to find the k, you would do x times y. So that's how you would find the k values for those. Now, the first thing we have to be able to do with this particular information is I need you to be able to tell if something is inverse, direct, or neither. So tell if x and y are a direct variation, inverse variation, or neither. So all relationships in math are either direct, inverse, or neither. So we're going to look at some different examples. One thing you can do that with, of course, you can do that with the equation. So let's say you have the equation x times y equals 5. Now, if you already know that's how you find the constant, you could say that that's inverse. You could also take this and just solve it for y. If you get the y isolated, what you'll end up with is y equals 5 over x. That makes it very clear that this is an inverse variation. You could have an equation like y equals x minus 4. This being solved for y, I'm going to compare it to my variation equations. And this -4, this addition or subtraction of a constant, is in neither of these. There's no addition or subtraction in either one of these variations. So this would be neither inverse or direct variation. I'm running out of space. I'm going to squish this in the corner. What if you have y over 2 equals x? It's also not clear directly from looking at that which one it is, but if I isolate the y, it'll be easier to see. So to isolate the y, I'm going to multiply both sides by 2. So y would be equal to 2x. Then it's very clear once you've isolated the y that this is a direct variation. You can also do this from a table. So let's look at a table and see how that would change our work. So example 4, let's say I have a table. And, let's do a sideways table. That would be fun. Ooh, x, y. Here we go, sideways table. My x's are 2, 4, 6, and 8. My y's are going to be -12, -6, -4, and -3. So again, what I'm going to be looking for is I want to see what the k is. Because if I can find a constant of variation by doing y over x, then I know I have a direct variation. If I can find the constant of variation by doing x times y, then I have an inverse variation. So let's see what happens here. So if I do y divided by x, I would get right here negative 12 over 2, which is negative 6. Okay. I would have, let's see, y divided by x, negative 6 over 4, which is negative 3 over 2. These are not the same. So that's not going to work. Let's see if, so we did this one. Let's try this one. X times y. X times y is going to be negative 12 times 2, which is negative 24. Cool. I also have negative 6 times 4, which is negative 24. Okay, this is working right here. I have negative 4 times 6, also negative 24. Beautiful. Right here, negative 3 times 8, which is also negative 24. So since this is my constant of variation is x times y, I get that from the inverse variation. So this problem happens to be an inverse variation. You can have a table that's straight up and down. So let's say we have like one of these. Here we go. Let's do 1, 2, 3, 4 for the x's. 1, 2, 3, 4. That's easy. And then let's do like a 2, 4, 8, 10 maybe. Yeah. Okay, and we're going to look at our two options. So one of the options is y over x. So let's see what that would give us. Y over x, that would be 2 over 1 is equal to 2. Okay, cool. Then I have 4 over 2 is equal to 2. Life is good, life is good, life is good. I also have 8 over 3. Oh, 8 over 3 is equal to 8 over 3. So, that didn't work. I also have 10 over 4. That's the same thing as 5 over 2, so that didn't work out. Okay, so let's try x times y and see if we get a constant there. Okay, cool. So 2 times 1 is 2. 4 times 2 is 8. Oh. 8 times 3 is 24. This is not working. This is not working, so that's not going to work either. So neither of these work, so this is neither. Okay. Let's look at a direct, just for an example. Let's see. So example 6. Let's take a little table here. Let's say we have, for our x's, I have 2, 4, 6. And for my y's, I have 12, 24, and 36. You may be already able to tell that this is linear by looking at that because we are familiar with linear equations and their patterns. But just let me show you that the constant of variation is there. So if I try y over x, I have 12 over 2, which is 6. I have 24 over 4, which is 6. And I have 36 over 6, which is 6. And so that is just a confirmation that this is a direct variation, which you may have known because you can see the linear aspect of it. Okay. The next thing you'll have to do is they'll give you these variations and they'll give them to you in words. So let's look at an example of getting this variation in words. Okay. So what they'll say, and this is the word problem will say something similar to, it'll say in there somewhere x and y, or it'll say, in this one it says x and y vary inversely. That comment will be in there somewhere. And then they'll give you some values for x and y. So they'll say something like y equals 4 when x equals 3. Okay? And it'll ask you to do two things usually. It asks you to write an equation that relates x and y. So that is one of the things they'll ask you to do. They usually ask you to write the equation that relates the two. So you'll have an equation with an x and a y. And then the second thing they'll ask you to do is to find a value. So in this case, let's find y when x equals 2. So there'll be two requests. One of them will be to write an equation. The second request will be to find a value. Okay. Now, they will tell you in these word problems how they want this to vary. In this word problem, they want it to vary inversely. So I already know that the form of the equation I'm going to be using is y equals k divided by x, because that's the inverse equation. Now, to provide the equation that they requested right here, I need to know the value of k. I'm going to use this information here to find that value. So when y is 4, x is 3. Awesome. Well, I can use this to find k. To find k, I would simply need to multiply both sides by 3. Once I multiply both sides by 3, I can see that k is equal to 12. So in order to answer the first question to write the equation, I would have y equals 12 over x. And that would be the inverse equation that matches this situation. The second thing they'll ask you to do is to find a value. So they've asked me to find y when x is 2. So I have an equation. The equation is y equals 12 over x. They just told me x is 2. So that means y equals 12 over 2. So y must be equal to 6. And that's the answer to the second thing that they asked me to do, right? So if x is 2, y has to be 6. You could also have like a fancy schmancy word problem. So let's look at like a fancy one, like an applied math word problem. Give me one second. Okay, so let's look at something that looks more like a real world problem. So it says the time t it takes volunteers to build a playground varies inversely with the number of volunteers n it takes, with the number of volunteers n, period. It takes 10 volunteers 8 hours to build a playground. How long for 30 volunteers? Okay, so let's look at this. It says already that it varies inversely. It says time varies inversely with the number of volunteers. So the inverse equation, y equals k over x. So time is going to be our y, and x is going to be the number of volunteers. Now remember, to have a working equation, I need to have k. Now they tell me that 10 volunteers can do this in 8 hours. So 8 hours should equal k over 10, which means, and I'm going to come up here because I'm out of space, which means k is equal to 80. Awesome. So the equation I need to work this problem is going to be, not y. I don't want a y. I don't know where my whiteout is. Not y. T equals 80 over n. This is the equation that's going to help me solve this problem. Okay, now let's try to answer the question. So the question says, how long will it take 30 volunteers? Okay, 30 is n. So I have t equals 80 divided by 30. So the time is going to be 8/3 hours. Let's talk about how long that is, because when your boss says how long is it going to take, you would not say it's going to take 8 over 3 hours. No one does that. So let's think about that. Let's just take a minute, and I'm just going to come to the side and kind of do some head work, okay? I'm actually going to squish it down here. So 8 over 3 is going to be equal to 2 2/3. Now 2 hours is easy. I need to know what 2/3 of an hour is. So I'm just going to take an hour, and I'm going to mark it, and I'm going to make it into 3 sections. Now an hour, a whole hour is 60 minutes. If I want that in 3 equal sections, each section would have to be 20 minutes, right? Because 20 plus 20 plus 20 is 60. Well, I need 2 of the 3. So this one and this one. So 8 over 3 hours is going to be the same thing as 2 hours and 40 minutes. And that would be the answer to the question. 10 people can do it in 2 hours and 40 minutes. And that's how we use direct and inverse variation.